Hello and welcome to Learn Live. My name's Dean Bryen, and today we want to be talking to you about cloud security and all things cloud security. I'm a principal cloud advocate here at Microsoft, which means I work with engineers and developers to help them understand our products and advocate for them on behalf of them to our engineering teams to hopefully make our products better for them. I'm joined by Christina Pardali. Christina, do you want to introduce yourself?
Hello, I'm a Microsoft Learn Student Ambassador and I'm studying electrical and computer engineering. And I'm really happy to be here with Dean and present you about cloud security.
Awesome, and we're so lucky to have you here, Christina, as well. What we're going to do today is we're going to go through a Microsoft Learn module in an interactive way. So rather than you sitting down and reading the module, you can walk through with Christina and myself, and we're going to teach you all of the stuff that's covered in the Learn module. It's completely interactive. We're going to do some demos. We'll be telling you some of the core concept, and there's also a way for you to interact as well. If you join us over on Learn TV, you will be able to participate in the chat and ask questions, and we have a great team of moderators in the background helping answer them, and some of them Christina and I will do our best to answer on air, won't we, Christina?
Yes.
So the Learn module we're going to be going through today is the cloud security module, which you can see here at aka.ms/cmu cloud security. So let's have a look at what that encompasses. First of all, we're just going to look at the introduction, which you're kind of in the introduction now. We're then going to talk about cloud security responsibilities. We'll look at threats to applications and our environments that run in the cloud. We'll look at encryption. And we'll try our best, Christina, won't we, to explain encryption. It's not the most obvious thing. And then we'll look at data security and some integrated tools that you can use in the cloud to secure your environments. And then we'll summarize that all up and give you some key takeaways that you can take away at the end. So I'm excited to get started. Christina, what are you most excited about?
I'm really looking forward to the part of encryption because, as you said, it's not very easy in the beginning, but I think we will try our best to explain it.
Yeah, 100%. We'll do our best, folks. And you can let us know in the chat too if you think that we did a good job at explaining it or not. We can only go get better from here, I guess. So we have a couple of learning objectives, which I'll let you read a couple of those. They're quite long, but ultimately, take your time to read this for a couple of seconds. And while we're going through this module, this is what you should come out with at the end. These are the objectives of what you aim to learn at the end. And as we've said already, this session is live and interactive. If you're watching us on Twitch, YouTube, Twitter, welcome. But you can get more an interactive experience if you head over to Learn TV, where we have the interactive chat on the right-hand side. You can get there by just going to aka.ms/learnlivetv. So head over there, and we look forward to participating with you in the chat as well. So, first of all, Christina, we want to understand our audience, don't we? We want to understand what's going on. So we're going to put a question now in the poll for you to answer. We'd like to know which most closely describes your current role. So Christina, I'm guessing here you would probably tick A?
Yes, as I said, I'm a student and I'm studying electrical and computer engineering. I'm in the final year of my studies.
And just finished lots of exams, which is good.
Yes,
finally. So you can have a bit of breathing space now. I kind of balance between C and D here. I don't know whether I'd be considered as a developer or an IT pro administrator. I do a bit of everything in my kind of role as a security advocate. So person of a few trades there, I guess. So do we have any answers coming in from the audience, Christina?
Not yet, but you can answer live and we will. Okay, so as I see, 20% are students and 40% of the people are professional developers and another 40 professional IT pro administrator.
Nice.
And it's changing. It's changing.
Yeah.
So.
It's going to update, I guess, but that gives us a good mix, right? We've got some professional developers and IT pros here, as well as some students. So welcome. Hopefully there'll be content that's relevant to all of you here if you want to learn a little bit more around general concepts around cloud security, which is what we're going to talk about today. So the next thing we want to know is if you've used Microsoft Learn before. Now, Christina, I'm think I know the answer to this one for you.
Yes, of course, I have used it. It's a great starting point, especially for students if you want to learn. And there are a lot of topics that Microsoft Learn you can learn from there. So
yeah, it's great. I personally use Microsoft Learn for stuff that I want to pick up and learn. We'll talk a little bit later around some certification paths and how you can get them on Microsoft Learn. I find them super valuable. And it's just I don't know the figure, and I'm not going to quote it because I don't want to get it wrong, but there are tons of resources on there. How are the audience getting on, Christina? Any answers filing in yet?
Yeah, 58% until now had said yes.
Okay, cool. So that means that there's my maths is going on. 42% haven't used it before. So by the end of this, you'll be familiar with what to expect from a Learn module, obviously in a more interactive way, but this is the kind of learning objectives and outcomes that you can get from leveraging this awesome platform that we have available to you. So now we know our audience, Christina, and we understand them a little bit more. Let's dive into a bit of a security introduction, shall we?
Yes.
So I don't want to scare the life out of everybody watching this, but the reality is that as you're watching this session right now, information systems are under attack. They're under attack from bots that are trying to do application scans and find vulnerabilities in web applications, from port scanners looking for open ports on firewalls and access to particular systems. There are human hackers trying to hack people more targeted with things like phishing campaigns via email and stuff like that. They're looking for passwords and credit card numbers in data. Unfortunately, this is just the scary world that we live in, right? I haven't scared you too much, have I? Yeah. So the reality here is that there's no end to which the bad guys won't go to steal your data and basically wreak havoc in an organization. This always makes me laugh, this GIF here, because this is like the typical movie hacker. They put on their dark clothes, like I've fit the bill today. I've got my dark top on here, and then they chuck on their sunglasses and type crash override into system. But the reality is that this isn't what a hacker looks like. Hackers every single day are just normal, ordinary people that are really smart, and they're trying to break into these systems. So the point here is that it lies to us as cloud and IT professionals in order to secure these environments, right? And how we can defend against such attacks.
So Dean, where can someone learn more about this kind of attacks?
So if somebody, it's actually interesting. So I spoke about the kind of bad hackers here, the bad actors, but you can actually build a whole career as an ethical hacker, which means you basically get paid to break into people's computer systems and test them for security vulnerabilities. And I think that's probably the coolest job in the world. I don't know about you, Christina. But also learning these skills, I feel that if you want to defend against an attacker, you need to understand the attacker's mindset. So there are a couple of courses and certifications that people can take. One very kind of entry-level one is the Certified Ethical Hacker course, which is pretty good, from EC Council, as well as there's a wealth of content on the OWASP Foundation. They're the open source foundation for application security, and they have so much content that people can consume in this space. So if you're interested in this, the more offensive type of security and being able to do this ethically, of course, I wouldn't condone any other way, then head over to those resources. So when we're looking at securing our environments in the cloud, it's a three-pronged affair. It's not one person's responsibility to look after security in the cloud. And Christina, we spoke about this before, right? How there's often a perception sometimes that the cloud is going to take care of everything, right?
Mm-hmm. Yes, exactly.
We've seen that before, but actually there's kind of multiple stakeholders here in making sure our environments are secure. It's down to the software developers to make sure that their application code that's running in the cloud on top of the infrastructure and the servers, etc., is secure and doesn't have application vulnerabilities. It's down to the cloud administrators who are building the resources that the developers build on top of in the cloud environment. The people that are provisioning the servers, that are patching them, that are configuring the virtual networks and the firewalls, it's their responsibility to make sure that they're adhering to best practice as well. And then finally, it's down to people like us, Microsoft and other cloud providers who actually build in the cloud platform to make sure that the underlying platform that everybody is building on is secure too. The reality is that all it takes is one weak link in the chain to kind of break in. So it's for everybody's responsibility, and we all need to work together. And we're going to talk in a little while about cloud responsibilities and who's responsible for what, and how you can make sure that you're not kind of falling for any of the low-hanging fruit, and you're covering the basics.
So is there anyone else in the company who should care about cloud security?
Yeah, it's a good question, Christina. I think there is, yeah, of course. Everyone should care about cloud security in a business, right? From the finance department should care about it because of the loss of reputation or the cost of a breach should that happen, all the way through to every single developer and engineer and technical professional, as well as people like product managers who are building products and they care about the product. And often we find in organizations, this may ring true for people that have worked out in the field already, that product managers who own products, they just want to ship features, right? Say you created Microsoft Teams, right? You just want to make Teams so awesome for all of your customers, and you want to just ship all these cool features. But they need to be aware that sometimes we need to stop shipping features for customers and implement security improvements and enhancements to our environment as well. So let's look at some of the cloud security responsibilities and how we really just look after security in the cloud. So the point here around security responsibilities is that the security is implemented by us. The systems that we use are merely tools, but ultimately it's a process that is implemented by people. Another scary fact, I'm full of scary facts today, no one can design an information system to be inherently and completely secure. The attackers always kind of have the advantage, unfortunately. They just need to find one little hole in our environment, but we need to protect the entire thing from every single possibility of an attack. So yeah, we need to make sure that it's all about the people and the process and having a procedure to make sure that our systems are as secure as we can possibly make them. Cloud services are great for us to do this because we share the responsibility with the people that build on top of the cloud. So it takes away some of that responsibility from users of the cloud, right? They're no longer responsible for the entire stack, which we're going to dive into shortly. So ultimately, what it comes down to is risk management. And the International Information System Security Certification Consortium, which is a tongue twister that I love to try and say every now and then. We can easily refer to this as ISC squared. They define risk management as what you see there on the screen. So it's the process of designing, developing, sustaining, and modifying operational processes and systems in consideration of applicable risks to asset confidentiality, integrity, and availability. What this basically means is that it's all about risk and managing the risk, having a process that helps us know what the risk is to our environment if something should happen, and just as importantly, knowing how we can react to that event should it happen. That's really, really important. So risk management might seem a little bit boring, but it's fundamental to IT security and in the cloud, right? We need to understand what the threats are to our cloud environments. We need to understand what the potential loss or risk would be should one of those threats happen, and then how we're going to recover from that event if it does, God forbid, happen. So another organization which is much easier to pronounce called the FAIR Institute. This stands for Factor Analysis of Information Risk, and they group loss into these 6 different categories. So what they're trying to do here is they're trying to assign a monetary value to a security event happening inside your environment. So you try and assign a monetary value to the productivity that might be lost, right? Your team would have to deal with a security incident. They definitely wouldn't be shipping features in the middle of a breach, right? There'd be all hands to the pump trying to get everything back online and working properly. Other ones here like reputation. What is the cost, the financial cost of the reputation to your organization should you suffer a data breach? Do you lose competitive advantage? Not necessarily by having a data breach, but by implementing particular security controls that may limit the functionality of your product, right? So we need to make sure that what the FAIR are trying to do is they try and allocate a loss. And the important thing to say about these here is that these aren't used one by one. So we won't say, Christina, right? We wouldn't say somebody's broken into our SQL database and they've stolen all of our company data. How does that affect our productivity? It doesn't really make sense to just look at productivity in that example. We need to look at all of these and say, well, how does that affect our productivity? How do we respond to that? What is the cost of responding to that? How do we, if maybe we need to replace goods or replace services? Are we going to get any fines from particular governing bodies or regulators that say that we broke rules by not securing our systems properly? And we need to evaluate all of these against a breach to understand, someone breaks into our SQL database and gets all the data, this is what that would cost to our business. And I appreciate this isn't super technical, but it's really, really important that as a company, when people are deploying applications anywhere, but in the cloud as well, they understand what the financial cost and risk is to their business should they incur a breach. Now, in order to do this and understand what the risk is and secure our cloud environments, which we're going to dive into shortly, we need to understand, we need to hire professionals, right? And people that know what they're talking about to implement this. That's right, isn't it, Christina?
Yes, so the people that are charged with maintaining the security for cloud service providers are typically the certified professionals. Their job is not only to protect their own employer systems and platform, but also their clients and customer services. So certification is not like a degree we take from the university. It's a frequently renewed statement that shows that someone has demonstrated proficiency in a specific set of skills. So the ISC squared organization backs the security industry's most recognized certification, which is called Information Systems Security Professional. And it also offers a more narrowly focused certification on cloud security specifically, which is named Certified Cloud Security Professional. Except from these two, the Cloud Security Alliance offers its own certification, which is called the Certificate of Cloud Security Knowledge. So Dean, do you have any experience with these certifications?
So you've just reminded me, Christina, actually, that I really need to go and do these two. The first two certifications have been on my to-do list for quite a while now. They are great certifications. They're very well recognized inside the industry. One thing to note, actually, as well, is that for people watching this that are students, those first two certifications, definitely the first one, I'll have to check on the second one, but definitely look this up if you're interested, do require some real world experience. So I think the CISP requires 5 years of experience working in the field. So this is definitely something that students can look at this and say, right, I'm going to go and get a career in cybersecurity, and I want to get my CISP in 5 years' time. That's kind of a really good goal, and spend that 5 years really understanding the industry and how it works in order to pass that certification. But what if people want more cloud-specific certifications, Christina?
Yes, Microsoft offers the Microsoft Certified Azure Security Engineer Associate, AZ500. Candidates for this certification should have subject matter expertise implementing security controls and threat protection, managing identity and access, and also protecting data, applications, and networks in cloud and hybrid environments as part of an end-to-end infrastructure. So a candidate for this certification should have strong skills in scripting and automation, a deep understanding of networking, virtualization, and cloud NTR architecture, and also it would be good to have a strong familiarity with cloud capabilities and products and services of Azure. So it's talking from a student perspective, I think it's a really good starting point for a student.
Yeah, definitely. Those networking exams you took a few weeks ago should definitely help you with that, Christina, right?
Yes.
The definitely a great place if you want specific security certification. We also released into beta security operations certification in Azure as well. And if you're not familiar with Azure at all, hopefully you've joined some of the previous sessions in this series and you've learned a little bit more around general Azure. But I'd recommend also taking the AZ900 certification, which is the Azure Fundamentals certification, to get a real grounding knowledge of Azure. But yeah, this is a great certification. And guess where you can go and learn about it, Christina?
On Microsoft Learn, as always.
Exactly. If you go over to Microsoft Learn, you can head over, just literally search for AZ500 Microsoft Learn. In fact, let's show you that actually. I'm going to just do a fresh search here for AZ500 Microsoft Learn, and you can just see it straight here. The first link that comes back on Bing will show you the exam. It will tell you the option to schedule the exam. But if you scroll down and make this a little bit bigger for you to see, you can see the skills that are going to be measured. And then it will tell you there's two ways to prepare. You can go and pay for an instructor-led course, but why do that when we have the power of Microsoft Learn, right? You can do this free content, and there's a bunch of learning paths and modules, just like the one you're going through today, that will help you understand all of the content required to go ahead and prepare for that exam. So securing applications, implementing resource management, network security, virtually all the stuff that you just mentioned, Christina, right?
Yes.
So if you're feeling keen to go and learn more about cloud security after today, that's a great place for you to go and check out more content on Learn around this. So we spoke about the sharing the responsibility. I kind of touched on this earlier, Christina. In the cloud, when we talk about security, it's a shared responsibility. We spoke about the cloud service provider, the cloud administrators, and the developers that are building on top of the cloud. Now, I want to give a quick whirlwind recap if people aren't familiar with the terms they see on the screen here. So the first thing I want to talk about is IaaS, or infrastructure as a service, and this is where we buy virtual machines in the cloud. This is the most kind of, I guess, control that we have as customers. I'm talking in the concept of a customer using the cloud right now. This is the kind of most control you have when using the cloud. You deploy virtual machines, but you also have more responsibility. You need to look after everything from the operating system upwards. If you leverage services like PaaS, which stands for Platform as a Service, these are tools like maybe Azure SQL Database, where we provide a SQL database as a service to you, or Azure App Service, where you can just deploy your apps to Azure. These are called Platform as a Service. They're a bit more opinionated, but the services are provided to you as a service. You can just throw your data into Azure SQL, or you can deploy your app to Azure App Service. This means that there's even less responsibility on you, and more is taken care of by the cloud provider. So we look after the operating system in that case. We take care of scaling, not just security responsibility, but other kind of operational responsibility in the cloud as well. And then finally, SaaS, or software as a service, is things like Office 365 or Microsoft Teams. There's much less responsibility on the customer, and the majority of the security responsibility lies with the cloud service provider. So this diagram here kind of shows that with this sliding. I think everything's mirrored. It's probably sliding that way. I don't know. One of those ways. This sliding responsibility model here that shows that if you're running your applications on premises pre-cloud and you're not using the cloud, then you're pretty much, well, you are responsible for everything, right? Even physical security, down to the lock on the door of the data center. But then as we move across that from infrastructure as a service to platform as a service to software as a service, you see that the slider goes up, and the cloud provider, which is the gray area, is responsible for more, and the customer yourselves is responsible for a little bit less. So the point here is that this kind of perception that you've spoke to me about, Christina, right? Yes. There's often this perception that the cloud provider, you put your applications in the cloud and they take care of everything for you. Well, unfortunately, that's not true, but it's not a bad story. This is great, right? You get to stand on the shoulders of giants. Microsoft invests over $1 billion per year in cybersecurity. I don't think that most organizations in the world invest that much money in cybersecurity. And if your organization doesn't, then you get to leverage the power of Microsoft security and leverage these secure platforms that you can build on top of. So basically what I'm saying is deploying applications to the cloud makes your life a lot easier than it does running them on premises.
So do you think it is risky for me to put my resources in the cloud where I'm losing control of some security myself? It is not a problem?
It's a good point, actually. This was when I first started working in the cloud in 2014, it was all a bit new and uncertain, and people were very uncertain around whether they should deploy to the cloud. Unknown, but now we very rarely get that challenge at all, Christina. In fact, the cloud is seen as secure, and we've even heard large companies, enterprise CIOs say on stage that actually they can do this better than I can. right? These major cloud providers can do this better than I can in terms of securing their environment. I don't have the resources to do that. So you're definitely leveraging in fact, here in the UK, where I'm based, the National Centre for Cybersecurity actually sent out a document to all of their organizations, the government organizations here in the UK, saying you should definitely use the cloud and you should definitely use platform as a service in the cloud, because you get there's less responsibility for you and it's more secure than you can probably do it yourself, organization X, Y, or Z. So yeah, we see this as the opposite to that, actually, Christina.
Okay, perfect.
So hopefully everyone's been listening so far and we've kept your attention. So how about a knowledge check, Christina?
Yes, you can answer live all the questions so that we can check the answers together. Beginning with question 1, which is true or false. When IT infrastructure is moved to public cloud, the cloud provider assumes all responsibility for the security of that infrastructure and the applications that it hosts. And we have two choices, true and false. So according to my opinion, as we said, we have the shared responsibility model. So the responsibility is shared between the cloud provider and the cloud customer. So I would definitely put false to that.
Yeah, I think there's we spoke already about this perception, right? Already about the cloud provider assuming all of the responsibility. Sometimes people think that, but of course there is a responsibility for the customer as well. So I have to agree with you on that. How are the answers looking from the audience, Christina?
Let's see. So 100% said false.
Well, it looks like people are probably listening, so that's a good thing.
Yes.
Everybody got the answer right, so we don't have any prizes, but you can give yourself a pat on the back every time you get a question right. Next one. So
the ideal factor analysis of information risk FAIR is to A, assign a monetary value to cybersecurity risks. B, enable root cause analysis for cybersecurity risks. C, enable perpetrators of cybersecurity attacks to be identified. And D, provide cutting-edge defenses against cybersecurity attacks. So let's take it one by one. A, I would say it's true, because this is exactly what you said about the purpose of the FAIR organization.
Yeah, let's go through the other ones as well. We won't want to give too much away, do we?
Okay, so B, can you explain why it is not true?
Yeah, so we should try and enable, if possible, a kind of root cause for any. But this kind of answer doesn't actually make sense now. I'm reading it, Christina. We don't really do root cause analysis for risks. We would normally do root cause analysis for failures or incidents that had happened. A risk is something that might happen. An incident is something that has happened. So it just doesn't make sense. And even if it did say for cybersecurity incidents, that's not what we're doing with FAIR, right? FAIR is all about loss and yes, calculating that loss.
And of course, C is not true, because the FAIR organization doesn't have to do with identification.
Yeah, exactly. Yeah, that's very true. Yep.
Let's see what the audience has to say about that. One moment. So 55% said A, and some people said D.
Cool. Yeah. So to answer that to the audience there, the people that answered D, it doesn't provide us the FAIR process that we spoke around, where we categorize losses into those 6 categories, and we try and get a monetary value to those risks and see if X was to happen, what would that cost to our business. It doesn't provide us with any defenses against cybersecurity attacks. It just provides us with some kind of insight and that we can use to decide whether we are going to implement a particular security feature or not. Imagine that we're at an organization, right? And somebody says, what's a good example here? There's a risk that somebody could upload a malicious payload and potentially do a SQL injection and get the data from our SQL database here. And then someone say, right, okay, well, how do we fix that risk? And somebody says, well, it requires a whole rebuild of the entire software system. It's going to take about 4 weeks of engineering work, blah, 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 right? what we could do with Fair is say, well, what is the risk there, right? What is the cost? If that was to happen, what would the cost be to us, right? So say, well, actually, it's going to cost us £1 million or dollars if that happens. And they say, well, go spend the 4 weeks building it, right, and improving it because the cost is huge. It just gives us another indicator that we can use in the calculation. Say, are we willing as a business to accept that risk, or is it something that we need to kind of resolve and we're not comfortable with an action right away? So yeah, most of the people there were right that the answer is to assign a monetary value.
Okay, so question 3. Your organization hosts a public-facing website in Azure App Service. According to the shared responsibility model, who has responsibility for securing access to these services through identity and access management? A, you, the customer, B, the cloud provider Microsoft, C, both you and the cloud provider, D, the third party hired to audit the site security configuration. So let's see D, the option D. Maybe I would say it's true. What do you think?
So I think if we hire the point here is that if we hired a third party to audit the security of our site, they would probably be responsible for letting us know that potentially the identity and access is weak and open, but it's not their responsibility to secure it and to implement it, right? They're just auditing the environment. Generally, these kind of auditors are there to test and make us aware of gaps in our system that we can then go and fix. We don't really talk about third parties like that in the shared responsibility model much, especially in the concept of auditors. So how about another one?
It's not A or B because it's the shared responsibility model. So as we said, everything is shared. So C, it's true.
Yeah, and how are the audience getting on?
Let's see. 63% said C, both you and the cloud provider, and 38% said you, the A.
So the reason that it's both you and the cloud provider is that identity and access management is something that you need to configure in your environment, but also for the underlying resources, Microsoft as a cloud provider or any other cloud provider need to control the access management to any underlying resources that maybe their engineers need access to and things like that. So there is a responsibility for both, and yet we call it the shared responsibility model. On that diagram that we showed, identity and access management was actually half grey and half blue on the platform as a service column to show that it was a joint responsibility. All right, so I think everyone did pretty well, don't you think, Christina?
Yes, pretty well.
Again, we haven't got any prizes, but give yourself a big pat on the back, and we've got some more knowledge checks coming up to make sure. Any questions that you have around any of those, any questions about the questions, that's pretty meta, or any comments you want to make or anything you want us to answer, just throw any questions in the chat and we will answer some of them live on air, or our wonderful moderators that are sitting in the background will answer them as well. So let's move on to threats to cloud security and what kind of threats we have towards the cloud. So the thing I want to look at first is how, not necessarily what the threats are, but how organizations see what the threat is, what's holding them back from adopting the cloud. So this is a survey from the members of ISC Squared from 2019, and organizations are asked, what are the biggest barriers holding back cloud adoption in your organization? So some of this was around budget, but a lot of this mainly was around data security and loss and leakage. And when you actually look into it, 26% said that it was a lack of staff, resources or expertise. I think I saw somewhere this week that there's going to be 3 or 4 million shortage in cybersecurity professionals in the world. The skills that are required to secure resources in the cloud, what you're learning right now, and what you'll learn if you continue to learn from this is super valuable to organizations. In fact, I have some stats here that say that 28% of respondents to this survey said that they'd experienced a public cloud related security incident over the last 12 months. So this is happening, and of those that admitted to an incident, over a quarter of them, or 27% of them, said that their data was exposed through unauthorized access. And 1 in 5 experienced a breach, admitted their systems had been infected with malware, and 17% said that they were victims of an exploit to a vulnerability. Now, the scary fact here, God, how many scary facts are we going to give today, is that Gartner produced a statistic a couple of years ago, maybe 2019 or 2020, saying that 95% of security incidents in the cloud are going to be the customer's fault. So go back to that shared responsibility model. There's a responsibility for you. 95% of incidents in the cloud have been caused by the customer misconfiguring their systems and having an open way for an attacker to make their way in. So it's really important that you have skilled people and staff that know how to secure these environments. It should be a high priority. What's kind of interesting over time is that when these public cloud services became available back in the late what do we call it, the noughties, 2000 to 2008 kind of time frame, and kind of through to to 2015, I would say, these kind of surveys were being held, and you would see that respondents often cited that the biggest concern for them was loss of control. Right, they didn't want to put stuff in the cloud because they think that they would lose control, right? And you mentioned this earlier, Christina, in your question to me, right? Should I put my stuff in the cloud? But over the years, you can see there at the bottom right that only 22% of respondents this year worry about the loss of control of their environments when they move to the cloud. And this shows that, to kind of prove the answer that I answered to your question earlier, Christina, is that the mindset towards the cloud has changed, right? People are much more comfortable using the cloud, and they understand that these cloud providers and the cloud service providers are building secure, resilient systems for them to build on top of. So the Cloud Security Alliance, we spoke about them earlier. They created this certification, right, that you mentioned, Christina, this cloud certification. So every now and then they publish this taxonomy of threats to the public cloud, and they rank them in order of importance. So the point here, the main point to mention here is that each of the threats that they categorize is capable of affecting all 3 service tiers. So we spoke about them earlier: infrastructure as a service, platform as a service, and software as a service. So let's look at what the threats they see to public cloud. These are the threats, and what I want to try and help you here is with what the threats are that you could face in public cloud and how you can defend against them, because that's the most important thing, right? What you want to take away from this is, I need to care about this, and this is potentially how I can solve that. So the first one, of course, and the #1 priority, is data breaches. This is a very broad one, right? Any kind of security instance, but the threat is that your data could be leaked from the cloud. So the thing that you need to do here is all around, really, and you're going to hear this a lot from me in the next 5 minutes or so, is access control. It's all about access control and making sure that only things, so like services, applications, and people that need access to data have got access to it. So it's not wide open. You haven't got wide open access, and make sure that your access control to these systems is secure. And then the other one that's really important around more application-based attacks is input validation. I can't stress enough, if you're a developer and you're watching this, input validation, input validation, input validation. Most vulnerabilities are due to people injecting SQL injection commands, code injection, malicious characters for cross-site scripting attacks. There's a whole bunch of these that you can avoid by just doing input validation. That's probably that's really important. Misconfiguration and inadequate change control. So this is an interesting one. We already said that Gartner said 95% of breaches are going to be the customer's fault. If you're watching this and you use the cloud, that's your fault. So normally that's through to misconfiguration, in my experience. And a lot of that is around just change control is important here, because in the cloud we can, and you watched any of the other series before this, we spoke a little bit about infrastructure as code and how we can actually template our cloud resources in a document, right? We can actually template and say as text, like, I want this resource, this resource, this resource, this resource, and deploy it. If we adopt and apply change control to those documents, and we only deploy to our environment using those documents, then we've got Git history, we've got peer reviews, we've got approval processes and release gates, all the stuff that you probably heard around in the automation session if you watched it. If you didn't, you can go back and watch it. It's a really great session. The change control is really important, and even if you're doing you're not doing Git or DevOps or any cool modern change control. If you've just got a change control process where someone wants to change something, they have to raise a change and somebody has to approve it, that's enough too. We'll talk a bit about this, Christina, when we talk about encryption, right? And this is around key management.
Yes.
Looking after your keys and your credentials, and just managing those credentials in a secure way and storing them in a secure way. In Azure, we have a service called Azure Key Vault, where you can securely store your keys and they're encrypted, and there's methods to use to access those keys. Really, really nice way for you to be able to store them keys in a secure space. Because if someone gets hold of your secrets or your keys, then depending on what access those keys have, it could be game over, right? Don't store them in your code. Make sure you're scanning your code for credentials. Another top tip as well. And this is one that I scarily see quite a lot, actually. The lack of cloud security architecture and strategy. And this is where people are kind of deploying all their stuff in the cloud, particularly at startups and smaller companies, and they're just not really thought about security or anything like that. I see this at startups quite a lot until when they get their first enterprise customer, and their big enterprise customer says, can you just let me know how secure this system is? And they're like, oh, security? We were supposed to care about security. We've just been building this cool startup for the last year or something. We see that quite a lot. So it's important from the way to fix this is easy, right? From the outset, make sure that you've got a good security strategy and you've got a security architecture, the framework for deploying your resources to the cloud. We actually have a framework called the well-architected framework in Azure, and that has a pillar for security that tells you how to make your Azure and cloud resources secure. So encourage people to go and read that as well. Another great learning resource if you want to take any cloud certifications. The next one is account hijacking. This is typically the classic model of someone maliciously gaining access to an account for their own gain or benefit when they're not authorized. The way to really fix account hijacking is pretty simple. We need to make sure that we, again, identity and access management, make sure that people have got strong passwords, make sure that people aren't using regularly used passwords, check against services like Have I Been Pwned to see if passwords have been breached, and encourage people to update them. But also, again, there's this concept of least privilege, and this is only giving resources access to things that they actually need access to. So least privilege is important here as well, because if someone did break into your account, Christina, if you had access to the entire environment, then the company's kind of, well, they're screwed at that point, right? They're going to get access to everything. But if somebody broke into Christina's account and she only had access to the systems that she was supposed to have access to, then happy days. You've been hacked. That's not so happy days, but at least the blast radius is much, much smaller. They can only access, and then they need to care about trying to do privilege escalation and try and elevate privileges, which is pretty hard. Next one is insecure interfaces and APIs, and this is an interesting one because the cloud is we have this portal interface, where this graphical portal interface, right, where people can go in and they can. We'll see it in a moment. Actually, we're going to do some demos, and people just need to make sure that access to that is locked down, and only the right people have got access. Again, it's all about access control and only the right access to the right things. If you're building APIs on the cloud, right, make sure that they're secure. Don't just have public APIs open to the internet unless you really need to. If people are writing data to a database, make sure that they're authorized and they are who they say they are. That's really, really important. This one's a pretty bit hard to solve, is the insider threat. So this is the, we'll use you as an example again, Christina, the rogue employee working inside the organization who isn't necessarily happy that they're what's going on, they're not having the environment. Maybe there's somebody who's left the organization. I don't know about you, Christina, how many times have you been in an environment? I've left the company before and still had access to stuff afterwards. Does that happen to you? Yeah,
it does happen, and it's not good.
Yeah, it's not good. So there's some simple ways to fix that. That is, make sure you've centralized identity system, so that if you want to just block someone out in Azure, in Active Directory, for example, then they're blocked. All of their systems are blocked, and use that for single sign-on to absolutely everything. And again, blast radius. If Christina goes rogue and starts wreaking havoc around the environment, sorry to pick on you there, Christina, I know you wouldn't do that. Then if you only had access to limited resources, then the damage that you could do and your blast radius would be much reduced, right? So otherwise says is central identity systems, you can lock these people out instantly, and look at least privilege again for blast radius. And the other interesting one, the final one here is around, or there might be some more, but the one here is around weak control plane. And this is around, actually, people often secure their data. So they secure the data they put in the cloud, they care about restricting that and making sure everything's got keys and passwords, but they forget about the control plane where they're actually administrating the environment and access to their Azure or AWS or Google cloud environment, and make sure people have got the right access to that. And then if we're using things like DevOps and we're doing continuous integration and continuous development, that engineering system that is actually deploying your code and managing your environment and your resources, that becomes one of your most valuable assets. And you really need to control access to that deployment pipeline, right? And that deployment system. Because you could do all the security checks that you want as part of your deployment. Like you have a process, right? Someone commits some code, you run a bunch of security checks. Evil hacker breaks into your pipeline, injects malware after you've done your security checks, and then you think everything's gone fine, it's deployed to the cloud. So making sure that your engineering systems and your control plane is secure is important as well. And then the one here is metastructure and apply structure failures. So this is really about the interface between the infrastructure and the infrastructure that the application and the infrastructure that it supports. So just understanding that sometimes you're just deploying applications to app service and you think you just care about your application, but what are the configuration settings for that underlying infrastructure that you have control of that you can change as well? Limited visibility, right? This is not being able to know what is going on in your cloud environment, what's being used. So there's two sides to this. One side to this is what we call shadow IT. And this is people going crazy with a credit card inside an organization and buying cloud resources, spinning up services without central IT or the company really knowing about it. So if the company has got centralized controls and governance that they employ, then I don't know, Joe Bloggs in the corner is going rogue with their credit card and spinning up all sorts of stuff without any controls. So some companies there will ban any kind of spending on credit cards or any expense reports claimed in on credit cards and only allow invoicing via the central finance team for cloud resources. The other side to this is actual visibility of usage and auditing. So cloud activity, right? If in Azure, and all other cloud providers do this as well, we have the, or major cloud providers do this, we have the activity log. Or it's kind of like an audit trail. So you can have a log for every single action that anybody takes inside your environment. And it's really important that you have that log and you monitor that log and you understand what's going on inside your environment. So if evil hacker or insider threat goes crazy or somebody breaks into your environment or gains access to somebody's credentials and starts doing something untoward, you can start looking and analyzing those logs and know what's gone on. This is going to be really important for incident response. And the last one, which is an interesting one, is around abuse and nefarious use of cloud services. I find this quite fascinating, but it's also a little bit scary around how we've seen in the past people get access to cloud environments where there is almost there's not really a finite number of resources, and they just spin up a bunch of really powerful servers and they start doing Bitcoin mining on them, or they use your cloud account as a botnet to spin up a bunch of servers, and then you end up with a big bill because somebody's broken into your account and spun up a bunch of servers. I know you found we spoke a little bit, Christina, before around ways to prevent this, and actually the cloud inherently does this for you. When you first create a subscription in Azure, for example, there are limits on the number of virtual machines you can create. And this is really useful, and it's not there to limit you at all. It's there because for this particular reason, if you want to increase that limit, it's something you can do. A lot of these are soft limits that you can increase via a support ticket, but it just gives you that kind of peace of mind. The other thing that you can do is you can limit use things like Azure Policy, which is a policy engine, which enables us to adhere certain policies to our cloud environment. So we can say that you can't spin up really powerful GPU-backed virtual machines. You can only spin up a certain number of virtual machine sizes which we use, which kind of helps a little bit from that kind of blast perspective. And you can even limit to particular regions or other for governance purposes. So Christina, there's sorry, go ahead.
Yes, we have one question from the audience. Andrew asks, for Azure, how do you ensure that your organization is adhering to secure configuration so that your secure vs not? Yeah,
it's a good question, Andrew. There are a few ways that we can do this. So I just spoke there about Azure policy. This gives us the ability to apply a policy to a particular Azure subscription and say that, for example, HTTPS only must be enabled on all of our app services. If somebody then tries to deploy one with just HTTP, then they won't be allowed to, right? That would be something that would be blocked. On top of that, policy really helps us kind of, what's the word for that? Kind of enforce that, I guess. And then we have integrated security tools, which we'll talk a little bit about in a while, things like Azure Security Center, which enable you to see security recommendations that you could fix. So you would be able to identify potential gaps in your configuration and ways that you can go and improve them. And I'm going to show that a bit in a demo later, so I'll be sure to show you where those recommendations are as well. So Christina, I don't want to scare people, right? The point to mention here as well is that these are the threats to public cloud and how you can solve them, but these threats and more are still possible on your on-premises environment. So these aren't new threats that have happened because you're moving to the cloud. These are just some of the threats that you should think about when deploying to the cloud, and how you can potentially implement controls to defend against them. And again, as we said earlier, with the shared responsibility model, there's less here for you to worry about than if you were deploying on premises. So you're kind of in safe hands there. So knowledge check, Christina, right?
Yes. Don't forget to answer live. So question 4, a system's personal information has been divulged due to an SQL injection vulnerability in the application. Does this qualify as a data breach? A, yes. B, yes, but only if the person or organization responsible for stealing the data can be identified. C, yes, but only if applicable state and federal regulations define it as a data breach. And D, no.
So should we tackle the long ones? Should we tackle the long ones?
Yes. Let's see. C. Do federal regulation play a role on that? I don't think so.
I think if a regulator defines something as a data breach, cool. But in my perspective, and in the perspective here, that if you lose data that wasn't supposed to be accessed, then that's a data breach, right? Somebody has got access to data they shouldn't have access to. That's not really relevant whether the regulators define it as one or not.
Yes. No. Mm-hmm. And B, I don't think it's true because we, of course, we want the person to be identified, but it's not a requirement for us to say that it's a data breach.
Yeah, exactly. I think it would be nice to identify the attacker, and unfortunately in a lot of cases these attackers aren't identified, but actually there's a good point to mention it. The more important thing in this situation, if anybody out there is watching this and they've been involved in a data breach or security incident, they'll know this. The most important thing is working out where this happened and fixing the hole, and then also recovering our data and restoring our servers back. So responding to these incidents and these data breaches is way more important than actually identifying the person. Unfortunately, identifying the person is great. We should always try and do that and work with authorities to do so. But it's not it's a bonus if we find the person, I guess.
Okay, so I would say A is true.
Yeah, and I agree. And how are the audience getting on?
100% said A.
Yay! We have a clean sweep. So yeah, the answer there is definitely A.
Moving on to the next question, which of the following statement is true? A, security threats targeting public clouds can affect only IaaS services. B, security threats targeting public clouds can affect only IaaS and PaaS services. C, security threats targeting public clouds can affect IaaS, PaaS, and SaaS services. And D, security threats targeting public clouds can affect only PaaS and SaaS services.
So we spoke about this one as well, didn't we, around the I think I mentioned it before we moved into the threats that I mentioned, right?
Yes, you mentioned it, and if I remember right, you said that all kind of services are affected.
Yeah, exactly. So how are our audience getting on? Do we have anything in yet from the audience?
Not yet.
They'll be coming in, they'll be filtering in. There's quite a lot for people to read here to go through. It's like IaaS, SAS, SAS, PaaS, IaaS. Yeah, so looking at that, unfortunately, it would be nice if they only affected certain services, because then we would go and use other services, right? I think I even mentioned there that all of these threats still applicable to on-premises environments as well, right? Yeah, so do we have answers coming in?
Yes, 43% said C, and 50% said C, and the other 50 said A.
Okay, so you are more susceptible to threats if you're using IaaS services. You're not more susceptible, but you are more responsible for looking after the stack. And the data shows us that in those scenarios, people just make misconfiguration, right? So it's probably more likely to happen in those environments. But actually, it doesn't matter whether you're on premises, you're in IaaS, PaaS, and SaaS. Security threats are relevant, unfortunately, to all kind of services that we use, and we should be aware of them. Specifically, the ones we mentioned there, the threat taxonomy from the Cloud Security Alliance, they specifically only mention threats that apply to all three services.
Another question. So your organization owns a public-facing website that requires users to log in. A hacker sends a malicious email to the employees of your organization containing a link to the login page that looks identical to the real login page in an attempt to trick users into revealing their usernames and passwords. What type of security threat is this attack? A. SQL injection attack. B. Cross-site scripting attack. C. Man-in-the-middle attack. And D. phishing attack. A lot of different types of attacks here.
Yeah. So what do we think? Should we start with A?
Good. I wouldn't say A, but could you explain what B means? What is cross-site scripting attack?
So a cross-site scripting attack is where somebody is implementing code in a place, normally on a website, where they shouldn't be. So maybe they do this in, like, imagine you had a form on a website and there was like a comment section for a retail site. They would put some JavaScript as a comment, and then that JavaScript would execute, enabling them to extract information that they shouldn't be able to access. Obviously, in a comment field, you should only be able to put text. So this means the application developer has done something wrong. Normally, link back to what I said earlier, they're not doing input validation properly. So they're not validating the input, and they're taking somebody input and doing something with it, and it's getting run as code. There's a famous one years ago where somebody did this as a tweet. They found a cross-site scripting vulnerability in Twitter, and actually published a tweet that had some code that whenever you viewed it, it made somebody retweet it. So then it kind of just went and spiraled out of control, because everybody that viewed it then retweeted that tweet. You can Google that. It's fascinating. But yeah, that's not what's happening here.
Yes, and I don't think C is true, man-in-the-middle attack.
No, we won't really talk about man-in-the-middle attacks due to time, but it's definitely not one of those.
Yeah, so I would say D, phishing attack, and it's something that happens to all of the people.
Yeah, I think most of us got that. I'm guessing, how did the audience get on with that?
Let's see. So 100% said D, phishing attack.
Nice. So let's look at the, oh dear, what's happening here? Let's look at, let's move on to encryption, Christina, which is the bit that you were most excited about. So let's see how we get on with this. This is always a concept that I always found quite hard to understand. So we're going to try and explain it in a kind of fun way, using graphics and all sorts of fun. But what is encryption? So encryption is basically a way to obfuscate data to everyone except for everybody except for those who are authorized to actually see it. In the internet, encryption is huge. You use it every single day. You're about to learn how, and you don't realize that you're using it properly. And in public cloud platforms, this is really, really crucial that we have this capability. We can encrypt data in two places. So we encrypt data at rest, so when data is resting in storage or in databases, but we can also encrypt it in transit, which is when data is being transferred, such as when we're accessing a website or online banking or something like that. So let's have a look at the different types of encryption. The first one we want to talk about is symmetric encryption. And yeah, we're going to try and do some kind of, myself and Christina here, we're going to kind of role play out the example of how this kind of works in an analogy for you.
So the best way to describe symmetric encryption is to use a briefcase. This briefcase has one key or code, and Dean and I, we use the same key or code to lock and unlock this briefcase.
So here we have Christina's briefcase. If I want to put a document into the briefcase, I'm going to need the key from Christina. She'll give me the key, and then I will unlock and lock the briefcase with that key.
So now the document is in the briefcase, and for me to access that, I will need the key. So then I can open the briefcase and retrieve the document.
Exactly right. So I'm going to send the key back to Christina, and then you'll go ahead and, as you said, open the document. So we're using the same key to encrypt and decrypt in this example. This is exactly how symmetric encryption works. We put data into a data store, we use a key to encrypt it, and then we use that same key to decrypt the data. What we normally use here is something called AES 256, which stands for Advanced Encryption Standard. This has been around for years. It's quite an old form of cryptography, but actually it would take billions of supercomputers, billions of years to crack AES 256. So the reason it's working and it's been around and it hasn't been updated is because it works, right? We've worked. So let me show you a little bit around how simple it is to implement symmetric encryption in the cloud. So there we are. So here I am in the Azure portal, and I've created a resource group here called CMU. A resource group is just a logical container for some resources. And in here I have a storage account. I'll make that a little bit bigger for you so you can see. And this is basically a storage container that we can store stuff in the cloud. We can store this in a storage container, which is just like a document storage. We can have file share. We can use tables like a kind of simple database, and we can even use a storage account to store data in queues. But just for the concepts of this whole storage account, I've got the option here for encryption on the left-hand side. So you can see here that by default, as soon as you come in here, encryption is turned on. That's literally how easy it is to encrypt your data at rest in the cloud. We will use symmetric encryption to encrypt your data in Azure Storage using keys that are managed by us here at Microsoft. If you don't want to use Microsoft keys, you are welcome to use customer managed keys. You can bring your own keys and we will encrypt that data for you using the keys that you provide. So you can simply do that by just selecting customer managed keys. And then I've already enabled this here. So let me. Here we go. So I can just select a key from a key vault. So we spoke earlier about Azure Key Vault, right, Christina? This was the secure service for storing our keys. When we talk about encryption, one of the most important thing is actually storing these keys. So what we can do is we can just select a key vault here. And I already have a key vault that I created earlier called CMU Security. And then inside that, I have one key called CMU Security Key. I can then select that, hit save, and then it will successfully update it. Now, this data that's sitting in a Microsoft Azure storage account, I think in the West Europe region, over in the Netherlands, is now being encrypted using my own key that I provided. Now, we need to remember the attack vector that we're defending from or protecting against by encrypting our data at rest is somebody breaking into a data center and physically stealing a disk. If they then tried to read our data, it would be deemed unreadable. So most people deal just happy with Microsoft managed keys, but if you're not, you still have the option to use customer managed keys here as well. So you probably see from this diagram here that we showed that I had to pass this key to Christina, right? So this works okay for data at rest, where data's in the same place and it's like a system like storage, which is using the key to encrypt and decrypt the data. But that's pretty insecure if we want to start transferring data over the internet, don't you think? We can't just be sharing private keys that have access to decrypt our data. So that's when we start using a different technology called asymmetric encryption.
Yes, so symmetric encryption is a little bit different, as Dean said, and the best analogy for it is to use a mailbox. So anyone can put mail into my mailbox, but only I can retrieve the documents, for example, because I have the key.
Yeah, so in this example here, all I need to know is where Christina's mailbox is. So she has two keys. She has a private key and a public key. The public key is public. She can share that with anyone. They're not the same key, but they are linked. If data is encrypted with the public key, the only thing that can decrypt that data and access it is what Christina has, is the private key. So what's happening here, Christina?
Example? Yeah, if Dean wants to share a document with me, first I will need to give him my public key.
Yeah, and then once I've got this, I can then go to the mailbox and place the document in, and in the tech terms, we would encrypt that with this key. In this example, we're just going to lock the mailbox or open the mailbox using the public key.
And then I can retrieve the document with my private key, which is the key that only I have.
Exactly. So as I said, the keys are both linked, but they're not the same, and you can only decrypt with the private key that Christina has and not the public key. So if we have the document back in the mailbox and evil hacker comes along and he's managed to get hold of the public key, because that's the bit that we shared over the internet, right? That's the bit that's likely to get intercepted, then that wouldn't be allowed and the potential hacker would get blocked. This is how the internet works. Every time you connect to a URL that says HTTPS in the browser, then you are connecting to a site that is using TLS or SSL, and that is using asymmetric encryption. You are you're exchanging public and private keys with the server of the website, and then you're doing that kind of TLS handshake between the two of you to get access to the data. So this is something this is called public key infrastructure, or PKI, and this is something that's used all the time. And as I said, it's something that you're using. This gets us over the problem of sharing that key across the internet, because we only need to share the public key. Now, Christina, I mentioned in the threats earlier, right, about the storing our keys. Mm-hmm. The problem with asymmetric encryption, or the challenge of asymmetric encryption, is making sure, Christina, that you store that private key as securely as possible, because if somebody gets hold of that, then they'll be able to decrypt all of the documents that was meant for you, right? So let's see a really, really quick way of how we can use a private key in Azure. So we'll go back to the resource group that I have here, which has a bunch of pre-built resources in Azure. I have an app service that's running here. So this is an app running in Azure. There's nothing exciting about it. If I go to the website, it's just the standard Node.js app that's running. I haven't run my own app. This is just the out-of-the-box thing. But then I can come along the side and click TLS/SSL settings. And then simply what I can do here is that by default, when you come into here, we have HTTPS only, and this is turned off. So this means that somebody would be able to access my site on HTTP. It's really, really important that you don't allow that, and that you go ahead and turn this on so that only HTTPS and people can only access your site via SSL. It's encrypted. Really, really simple. We basically have the ability to use HTTPS and TLS and asymmetric encryption on app service just out of the box. What we can also do here, we won't go through it in this particular session, but you can go and read about it if you want, is we will use certificates. So what certificates do is they stop people masquerading as somebody else. Very proud of the masquerade graphic that I found for the slide here, that hopefully reflects that. The certificates are used to ensure that we know that it came from who it's supposed to come from. So I said earlier that only the private key that's linked to the public key can decrypt it. And this comes into, we spoke about man in the middle. You asked earlier, Christina, about man in the middle attacks, right? If somebody was to send me a public key who I thought was Christina, I then encrypt that with my private key. Sorry, let me go back. Someone sends me a public key who I think was Christina. I then encrypt my document with that public key. I send it back, and then who can decrypt it? Well, Christina can't, because it wasn't encrypted with your public key. Someone was masquerading as you, and they will then be able to decrypt the document that I thought was meant for you. What certificates enable us to do is make sure that there's integrity there, and the person that sent it is who we think it is. And this works by using something called a certificate authority. Both parties, Christina and I, would agree to use the same certificate authority. Christina would send her certificate and her public key to me, and then I would check with my certificate authority that this actually came from Christina and this is actually her certificate. This is something that is used in TLS all the time, and sometimes you will get an error when you go to websites saying the certificate is not trusted or something like that. There's no certificate, or it's an unsigned certificate. This means that that certificate hasn't been verified or signed by a certificate authority that you or your browser particularly understands. So yeah, it's really important that we use certificates. You might hear the term X509, and this is just the standard for the format of the certificate that we use when doing public key infrastructure. So encryption. The future of encryption is bright. There's some kind of exciting stuff coming on, and we won't spend too much about this, but I want to kind of share that this area is evolving. One thing that I find exciting is homomorphic encryption, and homomorphic encryption enables us to kind of get information from an encrypted entity while it's still technically encrypted. So this gets away that problem I said about asymmetric key management and having to keep the private key really secure. Homomorphic encryption gets us away from that problem. And I don't know a ton about it, but it sounds super exciting. This is really early at the moment, and it's in the research stage. And the other thing which I know a little bit more around is encryption at runtime. So we spoke about encryption at rest, we spoke about encryption at transit, but we didn't speak about encryption at runtime. And encryption at runtime gives us the ability to actually encrypt our data while our code is being run. And this is done by using specific hardware, which actually has encrypted hardware enclaves on the device. So some really, really cool technology there where your code runs in a physically separate chip on the board that is encrypted. If you want to interest that, it's called confidential computing. We had the Open Enclave SDK, which Microsoft Research was a huge developer towards. So we have a product offering there, and that's a bit more advanced than homomorphic encryption. All right, so there's a little bit there about encryption. Let's go ahead and look at data security in the cloud. So for data to be truly secure, it must only be accessible to people who are entitled to it. That sounds obvious, right? A data breach occurs when an unauthorized party gets access to data that they shouldn't have access to. So data security and protecting our data is really, really important. So in the cloud, there's some ways that we can do that. First of all, we can adopt what's called a defense in depth. What do we call that? Defense in depth kind of method, I guess is what it's called, or topology. And this means that we have, it's like an onion, right? We have different layers of defense in our environment. We first do network prescriptions at the boundary, but also doing least privilege identity and access authorization controls. We're also doing auditing and logging and threat protection, as well as encryption in our data. So we've got that defense in depth. So if somebody breaks through one area of our environment, it will be a lot harder for them to kind of break into the next one as well. And there are a number of data security platforms out there that you can use to ensure that your data is secure. So some examples might be that you would log all of your data for compliance purposes. Right, we spoke a bit earlier around the Azure activity log, but also logs for access to data. You can do logging on your databases, etc. And some of these tools also enable you to automatically discover and classify sensitive data. We'll see an example of that in a minute. And then also log any changes to infrastructure. Somebody gone in and changed the network access controls around your database. If somebody does that, you should know about that. And we're not going to cover it today, but security operations and logging and auditing is a crucial part of security in the cloud. And the great thing about the cloud is in your on-premises environment, you don't necessarily know what all your resources are, but in the cloud, you can just ping an API and it will tell you all of your resources that you've got. So at least you know what your inventory is. Inventory management comes a lot easier. So this is a lot easier in the cloud. Another thing that we should do is in a cloud platform is tenant isolation. So in Azure, in AWS, in GCP, there are concepts of tenants. So these are customers, and tenant isolation is the responsibility of the cloud provider to make sure that your customer, Christina, doesn't have access to my customer, right? And make sure that that kind of works like that. So that's the responsibility of the cloud provider. But it's important to know that that's a kind of tried and tested security boundary that we're very confident with, right? The other thing that we can do is we can do more granular logical segmentation. So we can break our Azure environments down to different accounts or subscriptions. So I've seen different organizations here. There's an example here in the diagram that says that maybe the finance team have their own account and the marketing team have their own account, and the website team have their own account, and another team have, the IT team have their own account, and we do segmentation like that. And then you saw me use resource groups in the demo, which is a logical container for our resources. We can also break our resources down into smaller groups. So you might be asking, why is this important? Well, we can put access controls at each of these levels. We could say that Christina works in marketing. She only has access to the ad tech resource group because she does all the ad tech technology in the marketing team. Dean works in finance, so he only has access to the payroll environment because he's a payroll administrator. So we can really lock down access to resources here. There are a number of integrated security tools. This one here is the data discovery and classification tool in Azure SQL database. This gives us the ability to see things like confidential data, anything that maybe breaches GDPR in our databases, personal identifiable information, and it tries to identify those and let you know where that data resides inside your environment. Very quickly, I'll show you the Azure Security Center, which I mentioned earlier, and Andrew, you asked a question about that. The Azure Security Center gives us the ability to understand what the current security state is of our environment. So here we have a secure score. So I have 61% secure score, and you can go ahead and click improve your secure score. This is one of the features of Security Center. It's not everything it does, but it's a great way to understand what your security posture is. So if we go down here and I'll pick one of these subscriptions, you see actually this one particularly has 53%, but I can go down here and see all of the recommendations. So I can say actually I don't have encryption at rest enabled on my virtual machines, and 4 of the virtual machines in my account don't have encryption at rest. Slap on the wrist, telling everybody to do this, and I'm not doing it myself. So I can click in there and it will actually say to me what the problem is. It will tell me what the remediation steps are, and this is linking me to a particular document. And then it will ultimately tell me even which resources in my account don't have encryption at rest enabled. So I can go through and see that these 4 virtual machines that I have, I need to go and do that. So really, really neat tool to help us go and improve our security score and understand our security posture in the cloud. All right, so Christina, that's a bit of a whirlwind tour of cloud security, and we're almost coming up to time. So let's let people know, summarize what we spoke about and give us some key takeaways.
Yes, of course. So for the first part, where we analyze the responsibilities, it's important to understand and remember that cloud resources are under constant attack, and that the cloud is a shared responsibility, and both the cloud provider and the customer share responsibility for the infrastructure. Also remember that risk management is a key activity, and it's good to know the different types of security certifications that we mentioned.
Definitely.
For the second part, where we talked about the threats, it's important to understand the threats to cloud security and remember that you can defend everything, but you can do your best and you can have cloud security professionals in your organization to help you with that.
Yeah.
And from the part of the encryption, it's important to remember that encryption plays an important role in securing data both at rest and in motion. Remember the two different types of encryption: symmetric encryption, which is typically used to encrypt data at rest and uses the same key to encrypt and decrypt data. And of course, remember asymmetric encryption, which is known as public key cryptography and is frequently used to encrypt data in motion. And two more things from the encryption part is to remember that the greatest challenge to encrypting data isn't the encryption itself, but the challenge is how to store keys securely and securely exchange them between the interested parties. And remember that there are services like Azure Key Vault, which provide secure storage for the encryption keys.
Yeah, can't emphasize that one enough. You should definitely not store your keys in plain text anywhere.
And then from the last part, where we talked about data security, the best approach to data security is a multi-layered one that includes multiple defenses at multiple levels. And also remember that there are data security platforms such as Azure Security Center that can help administrators implement security protocols and see the recommendations. And
definitely. And actually, it's an important point there around the shared responsibility model that I forgot to mention earlier, is that although as a cloud provider, we're not responsible for the top of that model, we give you a bunch of tools that we try our best to help you secure the bit that you're responsible for. And some of these tools like Azure Security Center is a really good example of that.
We have one question from the audience. Does a public library for homomorphic encryption exist anywhere? Where can I find more information about this? I think you mentioned that before.
Yeah, so I think there is. I might have had it in my notes actually. Let me skip back to the homomorphic encryption bit. I think there definitely is a public library that that tells us about it. I don't have a link to it there, but we'll find a link and send it to you. Have you looked into it at all, Christina? I haven't actually looked into homomorphic encryption in too much detail.
No, neither do I.
I know this is something that Microsoft Research have been contributing towards, but I'm not familiar with the project name or code name, unfortunately. But it's definitely something we can find out. So don't forget that that's kind of wrapped up the key takeaways. So some key things you need to take away from this session. Don't forget that you can go and access this module in text form at ak.ms/cmu cloud security. You can go ahead and go through that, and there's plenty more security content on Microsoft Learn as well. This is actually the last of a session series that we've done in partnership with Carnegie Mellon University, who did a fantastic job at writing the initial modules here that we've gone through with you today. So there are previous resources you can access. You can see them there. These are all going to be available to watch on demand at ak.ms/learn-live. And to leave up the slide there for the resources, the Learn module is there, the session recording, and there's a survey here. Don't forget to head over to the survey and put the event code 12925 in to leave your feedback. It's really important for us to help us make these sessions even better. Christina, do we have any more questions coming in from the audience at all?
No.
So if you've got any more questions, fire them in. We'll be here for the next few seconds. But yeah, fire your questions into the Learn TV box. We'll be happy to answer any questions if we can. But otherwise, we just wanted to say thank you for listening. It's been a blast. Have you enjoyed it, Christina?
Yes, of course. I see one more question from the audience. Which are the best practices to protect our business from a data breach? So
there's lots of things you can do. That's a very broad thing, is the data breach. But the most important thing that you can do to prevent from a data breach is, in my perspective, is identity and access control, and making sure that only the right people have the right access. We often talk about this thing called zero trust in the security industry. And this means that you should always have what's called an assume breach mindset. So as a professional, you should always assume that you either have been breached or that you're going to be breached, which means that in that case, you would make sure you lock everything down, you make sure everything is tight, and you're not just relying on traditional security methods. One thing that I always like, someone said to me once, and it's really stuck with me, Christina, is that when I first started in the industry, we used to protect everything with network security, right? We would put a firewall on the outside and we'd have this perimeter security. And that's still important today, but that's just one of the layers of our defense in depth that we spoke about. If we have, somebody said to me once, if you were going to build a castle today, would you protect it with a moat and build a river or a moat around your castle? You wouldn't do that, would you? You'd have more advanced protection methods. So that's kind of the same thing here. When we're building in the cloud, there's better ways to secure your environment than just putting a firewall around it and letting everyone run loose inside. I think it's important that you apply defense in depth and zero trust and least privilege access management. So I guess if we don't have any more questions, we'll wrap up the session. Obviously, you can reach out to us anytime. Check out any more content on Learn TV. We look forward to speaking to you and seeing you soon on another session. Thank you so much.